Hello and welcome to OpenShift Serverless. Today part 2, Knative Eventing. My name is Ortwin Schneider. I'm Principal Technical Marketing Manager in the Hybrid Platforms Business Unit at Red Hat, and my focus is on serverless, service mesh, and creating solution patterns. So Red Hat OpenShift Serverless is an abstraction layer on top of the Red Hat OpenShift container platform, which allows developers really to start deploying applications in a standardized way. It is based on the Knative open source project, and it really provides a uniform integrated interface across the hybrid cloud ecosystem. OpenShift Serverless has three main components, which is Knative Serving. That was what we had a look in part 1. Then there is Knative Functions and Knative Eventing, which is an infrastructure for consuming and producing events that drive your applications. And today we focus on Knative Eventing. So Knative Eventing basically is a collection of APIs that enable you to use event-driven architecture with your applications. So you see here in the slide on the right side different APIs. So we have things like a channel, filter, event sources, subscription, brokers, and so on. So you can use these APIs to create components that route events from event producers to event consumers, known as sinks. Sinks can also be configured to respond to HTTP requests by sending, for example, a response event. The Knative Eventing components, they are responsible for interconnecting asynchronously all different parts of your distributed application. So events in Knative Eventing, they conform to the Cloud Events specification. So therefore, any event within the Knative system must be defined as a cloud event. And a cloud event is a specification for describing event data in a common way. So the goal is actually to simplify event declaration and the delivery across services platforms. A variety of sources can trigger an event. So you can have events from your specific applications, from cloud services, from different providers, from any SaaS system, or from, for example, from an Apache Kafka. So an event source is a Kubernetes custom resource which is created by a developer or an admin, and that acts as a link between an event producer and an event sink. In general, most of the event sources, they are more often an adapter than an original event source. So they kind of transform proprietary events to cloud events and emit them to sync. With Knative Eventing, there are three main patterns you can implement. There is source to sync, channel and subscription, and broker and trigger. And Knative Eventing uses a set of specific custom resource definitions for each of those patterns, which controls the event-driven communication between your serverless applications. So the first pattern we have a look on is source to sync. So this is the most basic eventing pattern. So the source is really responsible for sending the events to a sink. When you install Knative Eventing, you will have some event sources already installed. Like there is a ping source which you could use to produce events with a fixed payload on a specified cron schedule, for example. Now there are of course some drawbacks. So with this direct connection, you don't have any queuing support or back pressure support. There's only one service that can consume events, and you also don't have things like filtering and so on. Channel and subscription. Channels and subscriptions, they provide an event pipeline that routes events between channels by using subscriptions. So a channel is basically an interface between the event source and the subscriber. So it's a special kind of sync because you can store the incoming event data and distribute it to the subscribers. You normally use it as a normal pub/sub topology. You have two types of channels in Knative. There is the default in-memory channel, and you have an Apache Kafka channel. So the in-memory channel is really the default, and it does not provide any durability of your events and messages, as well as recovery or persistence. So if you really want to set something up for production, you would need to use the Kafka channel. And the subscription basically is responsible for connecting a channel with a service. So services can subscribe to channels via subscriptions. And once there is a subscription, it starts receiving events. And then we have broker and trigger. With broker and trigger, provide kind of an event mesh model. So brokers are also custom resources that define a central location to send events for delivery. It's very similar to channels. There's a difference because you don't have subscriptions, you have triggers. And triggers are also custom resources that connect a broker with an event sink, but they can also filter events before they are sent to the sink. So you can really filter on any attribute of the cloud event and distribute the event to different sinks. So this way you could implement something like a content-based router. And this filtering capability is also the main difference between brokers and channels. And there's even more with Knative Eventing. You have things like an event registry, where you can also specify event types with a custom resource, and there is some discoverability features in there to see, okay, what type of events do I have in my system? And you have things like serverless flows, like a sequence, which is for defining an in-order list of functions, or a parallel, which is for defining a list of branches, and each of them receive the same cloud event. So this allows you, for example, to implement conditional processing. Well, that's it for the overview, and now let us have a look at the demo. We have an OpenShift 4.10 environment with Knative installed, so you see the 3 projects on the left side. The first thing we want to do is just to make sure that Knative demo is installed correctly. So what we want to check is, first of all, the Knative Eventing configuration for the conditions. So let us check this. So we should see, as we do here, there is everywhere a status of true. So deployments available, install succeeded. This looks good. The other thing we could do is check for the pods in the Knative Eventing namespace. So there is a bunch of pods running. You see things like an eventing controller, some dispatchers. Here's already Kafka configured. This is why we have also some Kafka pods running here. So everything should be up and running and ready. In the ready state, this looks good as well, so we could proceed. Another thing, just to list our event sources. So you could use the CLI to list them by installing Knative Eventing. You will also have these event sources available. So for example, there is a Kafka source to route events from an Apache Kafka to an Knative sink, or there's an API server source where you can monitor kind of the lifecycle changes of Kubernetes API events. Now let's get started with the demo. So we create a new project, Knative Eventing demo, and jump into this project, switch probably to the developer view, in the topology view, and proceed. So nothing in there. The first thing we want to do, we create a new Knative service. This is just a basic service. We call it event consumer, and it will just display the cloud events it receives. So it's just logging out the actual payload, the complete cloud event. So it should be up and running. We have it here. So this is just like a normal Knative service running now. And we can list it as well. So we have a public endpoint. So we could now send cloud events directly to this consumer. And this is exactly what we want to do right now. We get the route and We use curl to send a post request. So cloud events, they're always transmitted with an HTTP post request. And what you need to specify are some headers, which are mandatory. So you see it here, there's a cloud event ID, say hello, a cloud event type and source, and our actual payload here, hello Knative. So this is what we have. Let us just, in this other terminal window, log the, or show the container logs. So what was the name? Event consumer. So let us get the logs here. You see also this, it has scaled to 0. Now when we send this cloud event, it will scale up our Knative service and will log out our event. Yeah, so you see it here, user container. We received the cloud event with our type and source and our actual payload. So this way we can directly send cloud events to our consumers. Now, the next thing we want to do is we create an event source. This one will send messages based on the specified schedule, in our case every minute, with a fixed payload of this JSON value ping to our sink event consumer. So we create this event source. So we also see it here in the web console. We have our event source sending messages directly to the sink, to our event consumer. It is scaled to 0, and this is kind of the source to sink pattern, right? So now we see it scaled up. So we received the ping event in our event consumer, and you see it here in the logs. So this is what we got. So now we have a different type. This is the Knative sources ping, and also the source. Where is this event coming from actually? So from this namespace, from this resource, and our payload, right? Now the next step, we want to introduce channels. So we want to decouple this event producer from the event consumer by introducing a channel. So we create a new channel and name it my channel. And in the next step, we update our event source and specify the sink. So to send all the events to our channel. This is what we do right now. And also in the web console, you see there is the channel. We have our event consumer here. Here is the channel, and our event source is sending now cloud events to our channel. But we're missing the subscription to actually react on events coming from there. So this is what we create right next. We create a subscription and specify the channel and our sink. So we want our event consumer to subscribe to my channel. You see it also in the web console right now. So now it is scaling up, and we see also here in the log file again. So let us check this. We received our ping event here. Now in the next step, what I want to do is we create a second consumer, which we just call event display. It is basically the same container image, and also subscribe to the same channel. Let's do that. Create a subscription, specify the channel and the sink. So now we have a second interested party in these type of events. So we see it here. Now we have the event display. So now when we when a new ping event is being emitted through the channel, so both pods will scale up and get the event, like you see here. So event consumer and event display both get the event. Let us check this. So event display was the name. Let us check if we also got the message here. And here we see it. So here's our ping. Now the next thing we want to do, we clean up a little bit, deleting the subscriptions and one of our service. We want now to use Kafka channel. And what we do right now is we create a Kafka channel. But first, let's check the Kafka configuration of Knative. So there is one resource, which is named Knative Kafka in the Knative Eventing namespace. And there you specify broker channels and event sources for Kafka. So let us scroll up a little bit. Here is the spec section. So here's a configuration for Knative brokers where you could specify the Kafka address, the number of partitions and replication factor, and you could basically enable it, right? So for broker, for channels, you can also specify authentication. There is Apache Kafka installed in a different namespace, and in our case I use this Kafka for backing our channels. You could also list the channel types available, and we should see two types. Yes, so we have the default in-memory channel and our Kafka channel as it is enabled, right? And this is what we do right now. We create a Kafka channel by specifying the type in this group version kind format. So we say, okay, we want to have a Kafka channel, and this should now also be available here in the web console. There it is. Yeah, but first, let us check now the topics available in our Kafka cluster. So by creating this channel, the operator has created a new topic which backs the events and persists on this topic all events coming to the channel, right? So let us do that and list the available topics. So here we are. These are the topics available. So we have some other topic, application topics, and this is our topic for the channel. All events which are sent to this channel will be persisted in this topic. So the next thing we want to do, we want to also use Kafka source to listen to events on a specific topic. In our case, we have here a Kafka topic that we want to create. So with the Strimzy operator in OpenShift, or the AMQ Streams product, which is basically the production version of Apache Kafka for OpenShift, you could use a custom resource to specify a new topic. This is what we do here. So we want to create a topic with some very basic configuration, and the topic name is serverless orders. So let us do that. We apply this topic in the namespace where the Kafka is, and let us check again the topics. Okay, so here you see we have the serverless orders topic. The next step is let us create a Kafka source, and this is also in a YAML file. You see it here. There's the Kafka source, and this is specified with the address of our Apache Kafka consumer group, initial offset, some TLS and authentication things, and also here the sync configuration. So we say, okay, everything that is coming to this topic should be emitted to this channel, to our Kafka channel. So let us apply this Kafka source, and whenever we get something on the topic, it will be sent to our channel. Now we need to create a subscription for our event consumer to actually get the cloud events from Kafka, right? So we create a subscription, and now it is complete. So when we send now messages to a serverless order topic, it will be handled by our event consumer. And this is what we do right now. So we again use the console producer script of Kafka to send messages to our serverless orders topic. Let's do that. So we execute this in the pod, and we have now an input prompt. So we could start, for example, say, okay, we have an order ID of whatever, and this is the customer name, which is Schneider, for example. So this is our order in a JSON format. Now let us send this one, and we should see that this event consumer is scaling up, right? And we also should see now in the logs here that we received the message. Or that was wrong. We need the event consumer. So here we are. So this is the cloud event now from the pod, and you see it here. So we got the Kafka event, the source, and you get additional data with Kafka, for example, the current partition and offset of the partition. And this is our actual payload, so our message. So we handled our order. So that was it. And now in the next step, we'll have a look at broker and triggers. Okay. Therefore, we create now a new broker. So we have the broker now, and we create a second consumer, a ping consumer. So here's our consumer, looks great. Now we create a trigger. So we want to get messages from our broker, and we want to connect them to our ping consumer that we've just created. But we filter them. We're only interested in cloud events with this type, which is dev Knative sources ping. So that means only ping events should be forwarded to our ping consumer. Now we can also list the trigger to see, okay, the conditions, everything is up and running, and see, okay, what is the broker, the sync, and so on. And now we need to update our ping event producer to send our messages to the broker. This is what we do right here. We specify the broker as a sync. So now every minute there will be a ping message to the broker, and this will be filtered and forwarded to our ping consumer. Now the next thing is you cannot by default, you cannot access the broker or a channel from outside the cluster. So if you want to access a broker, for example, from the outside, you need to create a route and kind of to expose the broker ingress. And this is what we do right here. So we create a new route. It looks like this. So we specify our host name and our broker ingress as the target. And that's basically it. This is what we will now apply in the Knative Eventing namespace. Let us do that. So we've created a new route. Let's check this in Knative Eventing. So this is now our external access to the broker. So we can now send cloud events to this address to trigger things in Knative Eventing. Therefore, we check the broker. If you describe your broker, you see the internal address of your broker. And the pattern is you have the host name, namespace, and resource name. So this is the pattern for addressing or sending messages to a broker. And now we've created a route for this internal service. And we need to use this as a suffix to our host name. So we need to specify the namespace and the broker name, right, to address it from the outside. So this way the broker receiver in Knative Eventing is able to know, okay, where to dispatch actually the messages. And let us test this one. So we again send a cloud event directly to the broker, right? This is what we want to do. And this is, for example, a different type. So we want to send an order from the outside, but this is now of type Knative order. And therefore, let us assign this other consumer to this broker, because currently we only have the ping consumer, and this one is filtered to only handle ping events, right? So what we do is we delete this subscription here. All right, we do it in Web Console, and then we create a new trigger. You can also do that like here with drag and drop. And then we filter by type and say, okay, Knative order. If I'm not wrong, what was the type? KN order. So this is what we want to filter. So our event consumer will now handle cloud events of this type. Let us do that. So we have now created a trigger. It is there. Perfect. Let us check here. We check again the logs of the event consumer. This is great. So if we submit this, we send a message to this broker, and the broker will then, or the trigger will then forward the message to our event consumer and scale it up. Let us do that. Check again here. You see it's scaling up. And we also should see now in the logs that our data is coming in. So it is working as expected. So this is the cloud event, and here's our actual data. So now we were able to access everything from the outside. Yeah, great. So with that, I'm finishing the demo today. I hope it was helpful for you. If you have any questions, please feel free to reach out. And if you want to get started with OpenShift Serverless yourself, please visit developersredhat.com, go to the OpenShift sandbox, follow this link, and sign up for a free account. So you get a free 30 days free access to a shared OpenShift environment. There is already Knative installed, so just log in and bring your own serverless workload into this cluster. You can do whatever you want. There is also a cloud-based IDE for you ready. So feel free to get started. Thank you very much, and see you next time with part 3, which is Knative functions.